I am Dr. Prashant Kumar Welding, Professor, Department of Mechanical Engineering Department, GIS College of Engineering, Kolani. My subject topic is Advanced Welding Technology, ME 703A, lecture number 18, Underwater Welding. So, welding in underwater. Underwater welding is being done under the water. This is the figure I am showing. This is a separate technique is used. Outline of this today's lecture: importance of underwater welding, need for underwater welding, requirement of underwater welding, difference between normal welding and underwater welding, principle of operation, classification, weight or dry underwater welding, advantages, disadvantages, risk involved, and safety, applications, future scope, references. Introduction. The first ever underwater welding was carried out by British Admiralty Dockyard for sealing leaking ship rivets between the waterline. Underwater welding is an important tool for underwater fabrication work. In 1946, special waterproof electrodes were developed in Holland by Van der Willingen. Recent years, the number of offshore structures, including oil, drilling rigs, pipelines, platforms, are being installed significantly. Some of these structures will experience failure of its elements during normal usage and during unpredicted occurrences like storm, collisions. Any repair method will require the use of underwater welding. Research into using dry hyperbaric welding at depth of up to 1,000 meters is ongoing. In general, assuring the integrity of underwater weld can be difficult, but is possible using various non-destructive testing applications, especially for wet underwater welds, because defects are difficult to detect if the defects are beneath the surface of the weld. This is the underwater welding, underwater structure, and this one is underwater. This is to be welded in underwater. How to weld this? So, underwater welder will go to the underwater and do the welding because it is from the base of the sea. This is the sea. Are you going to? Are you thinking to go do this by lifting? No, sorry. This can be done underwater. This welding can be done underwater. So, underwater welding is an important tool for repairing ships and structure under the water. What is an underwater welding? Many of us won't have heard of underwater welding, but it is actually a very important thing in many industries. Underwater welding includes a lot of different processes that join steel on offshore oil platform, pipelines, and ships, etc. Underwater, underwater. At present, underwater welding become more sophisticated and can be done deeper. Gas tungsten arc welding has been used to weld pipes at depth of 200 feet under the water. This is a picture. The welder is doing welding in the underwater. This is protecting equipments is keeping in your body, protecting equipments, and he is doing the welding as we do in the out here in the air. This cable is from the top of the maybe in the from the sea from the ship. It is being welder is doing the ship welding. Need for underwater welding to repair cracks in ships, bridge, and submarines. For quick purpose in underwater welding. For to construction of pipeline in undersea. To weld any crack in pipeline undersea. Requirement on underwater welding. Power supply requirement 400 amperes or larger. DC generators, motor generators, and rectifiers are acceptable power supplies. Number two, power converters. Three, welding generators, P setup. Number four, diesel-driven welding generator, amperage and voltage setting, gas manifold. Types of underwater welding torch. Underwater oxyacetylene welding torch, call it a deep oxygen bulb, flash arrestor, waterproofing surface electrode, epoxy 152, number two, LELAC 30-12093, and polyurethane surface electrodes are used in the underwater arc welding. Difference between normal welding and underwater welding. Underwater welding, number one, underwater welding and burning. This is 6,500 degree Fahrenheit to 10,000 degree Fahrenheit under the sea. Underwater metal sound different. It's high pitch but muffled like a siren entering. The turning. It dissipates quickly out into the waves. Ground welding in the electric arc, temperature is very high of the order of 6,000 to 7,000 degrees centigrade. For the gas tungsten arc welding, gas metal arc welding, flux core arc welding, and submerged arc welding processes. This is in the ground welding. And it up to 10,000 to 20,000 degrees centigrade for plasma arc welding process and well above the boiling point of the base metal and filler metal. Principles of operations. This is the welding circuit. Welding circuit must include positive type of switch, usually a knife switch, operated on the surface and commanded by the welder and is used for safety reason. When DC is used with positive polarity, electrolysis will take place and cause rapid deteriorations of any metallic components in the electrode holder. This is the power supply from the top of this coming, and this is the knife switch. This is the electrode, rotated electrode, waterproof electrode. This is workpiece, and the waterproof electrode holder. This is a circuit. For wet welding, AC is not used on account of electrical safety. And this is a circuit of the underwater DC is used and probably positive polarity. Two possibilities: electrode design. These copper-coated carbon graphite electrodes are specially made for arc water process. Number two, tracking, creating habitat cover over the weld spot. Underwater welding is classified into two categories. Number one, welding in the wet environment. Number two, welding in the dry environment. This is left side, this is dry environment, dry welding, and this is in the wet welding in the underwater. You can see this is underwater welding is welder is this welder they are giving enough training for doing the underwater welding. There are several schools out there for giving training. This is dry welding as usual in dry field welder is being wet welding. Simply means job is performed directly in the water. It involves using special rod and is similar to the process in ordinary air welding. This is the waterproofing electrode, barrel length. This is gas bubbles, gas cylinder. This is slag, and this is gas bubbles. Of the metal and slag droplets are coming to the well deposit, well deposit area, and this is a flux coating, and this is core metal core wire. So this is the wet welding. Principles of operations. The process of underwater wet welding takes in the following manners. The work to be welded is connected to one side of an electric circuit and a metal electrode to the other side. These two parts of the circuit are brought together and then separated slightly. The electric current jumps the gap and causes a sustained spark, which melts the bare metal, forming a whirlpool. At the same time, the top of the electrode melts and metal droplets are projected into the whirlpool. During these operations, flux covering the electrode melts to provide a sealing gas, which is used to stabilize the arc column and seals the transfer of metal. The arc bound in a cavity form inside the flux covering, which is designed to burn slower than the metal barrel of the electrode. Welding in the wet environment, as the name implies, underwater wet welding is done in environment where the base metal and the arc are surrounded entirely by water. But in wet welding, manual metal arc or manual metal arc welding is used. Special electrode is used and welding is carried out manually just as one does in open air welding. The increased freedom of movement makes wet welding the most effective, efficient, and economical method. Welding power supply is located on the surface with connection to the driver or welder via cable. This is the cable, this is the welder, this is the cable, this from surface, top surface or from the sea. Dry welding. Dry hyperbaric welding involves welding being performed at the prevailing pressure in a chamber filled with a gas mixture sealed around the structure being welded. The most welding processes: sealed metal arc welding, flux core arc welding, gas tungsten arc welding, gas metal arc welding, plasma arc welding could be operated at hyperbaric pressure, but all suffers as the pressure increases. Gas tungsten arc welding is most commonly used. Dry welding. The degradation is associated with physical changes of the arc behavior as the gas flow regime around the arc changes. The arc roots contracts and become more mobile. Of note is a dramatic increase in arc voltage, which is associated with the increase in pressure. Overall, a degradation is incapability, and efficiency results as the pressure increases. Although a large number of techniques are available for welding in atmosphere, many of these techniques cannot be applied in offshore and marine application where presence of water is of major concern. In this regard, it is relevant to note that a great majority of offshore repairing and surfacing work is carried out at a relatively shallow depth in the region intermittently covered by the water known as the flash zone. Advantages: cheapest and fastest method, tensile strength is high, easy of access the well pool, no habitat, no construction, no waste of time, rapid quenching, decreases impact strain and ductility. This is the disadvantage. Hardian embrittlement, cracks, poor visibility in water. Hyperbaric, that is dry welding. Hyperbaric welding is a welding in which a chamber is sealed around the structure to be welded and is filled with breathable gas, commonly helium contained 0.5% vapor of oxygen. At the prevailing pressure at which the welding is to take place. This method produces high quality weld joints. The gas tungsten arc welding process is employed for this process. The area under the floor of the habitat is open to water. Thus, the welding is done in the dry, but at the hydrostatic pressure, the sea water surrounding the habitat. This is the this is the structure, sealed chamber. This is a chamber where the welding is dry welding is performed. Is filled with breathable gas, commonly helium containing 0.5 bar of oxygen at the prevailing pressure. Dry welding. This is the dry welding picture of dry welding. This is the picture dry welding. This is picture of dry welding. This is a dry welding chamber. This is chamber where the dry welding is being done. These are all dry welding. This is a chamber where the welding is being done. Advantages of dry welding. Welder diver safety. The shock in the welder, wet welding, diver shock is a very important thing. Uh, is the danger. So welder and diver safety is there. So if it is in the dry welding, good quality welding can be done. Surface monitoring, you can monitor the surface. Non-destructive testing can be done. Disadvantages: high cost of process, training, etc. is required. Large quantity of costly and complex equipments. More energy is required. Cannot be weld if weld spot is at unreachable place. Risk involved and safety. Electric shock explosion. Precautions include achieving adequate electrical insulations of the welding equipment. Shutting off the electricity supply immediately the arc is extinguished and limiting the open voltage, open circuit voltage of manual metal arc welding, shielded metal arc welding set. So electric shock is a very risky because as any short circuit, so personal protective equipment must be taken care that can be taken care. And insulation is the very important that is to be taken care. Hydrogen and oxygen are produced during welding. Precautions must be taken to avoid the buildup of pockets of gas, which are potentially explosive. Risk involved and safety. Risk is the life or death of the welder diver from nitrogen introduced into the bloodstream during exposure to air at increased pressure. Precautions include the provision of an emergency air or gas supply, standby divers, and decompression chambers to avoid nitrogen. Inspection of welding zone, welding area. Application of underwater welding, offshore construction for tapping sea resources, temporary repair work caused by ship collisions or unexpected accidents, salvaging vessels sunk in the sea, repair and maintenance of ships, construction of large ships beyond the capacity of existing docks, Development. Wet welding has been used as an underwater welding technique for a long time, but still is still being used. With recent acceleration in the construction of offshore structure, underwater welding has assumed increased importance. This has led to the development of alternative welding methods like friction welding, explosive welding, star welding. Sufficient literature is not available of these processes. So star welding, explosive welding, and friction welding can now be done in wet welding, and this is the development part. Future scope. Wet welding is still being used for underwater. Wet welding is still being used for underwater repairs, but the quality of wet welds is poor and are prone to radiant cracks. Dye hyperbolic welds are better in quality than wet welds. Present trend is towards automation. Thor 1T hyperbolic orbital robot is developed where diver performs pipe fixings, installs the trace and orbital heads on pipe, and the rest process is automated. Future scope. Development of diverless hyperbolic welding system is an even greater challenge, calling for annexed development like pipe preparation and aligning automatic electrodes, wire drill, changing functions, using a robot arm installed. This is in testing stage in deep water. Explosive and friction welding are also to be tested in deep water. Future scope and development. Wet manual metal welding is still being used for underwater repairs, but the quality of wet weld is poor and are prone to radiant cracks. Dry hyperbolic welds are better in quality than wet weld. Third one, T hyperbolic robot is developed that diver performs pipe fittings. Development of diverless hyperbolic welding system is an even greater challenge in development like pipe preparation, aligning automatic electrode. This is in testing stage in deep waters. Explosive and friction welding are also to be tested in deep waters. This is the future. Some questions, two questions are MCQ. For underwater welding, which of the following process is not used? Electroslag welding, sealed metal arc welding, tungsten arc welding, gas metal arc welding. So code is there. So most of the cases, arc welding is done in the underwater welding. So calling for electroslag welding is not an arc welding and it is not being used in the underwater. So answer is electroslag welding. Which process is used for repairing of tracks and spokes of driving wheels? Electroslag welding, plasma arc welding, thermite welding, and electron beam welding. So this question is not relevant to uh, underwater welding, but it is a welding question of welding. Question number one, four options are there: electroslag welding, plasma arc welding, thermite welding, electron beam welding. So repairing of tracks and spokes of driving wheels, it is thermite welding, exothermic compound is there, so thermite welding is being used. So this is the answer of the question MCQ 2, and this is the end of the session today. We have discussed the underwater welding. One is dry underwater welding, and also one is another is wet underwater welding. So welding in the underwater welding requires some rigorous training of the diver or the welder. All over the world, there are training schools where the diver can give training for underwater welding because some precautions are to be required to take for safety of the welder. So thank you. These are the references underwater welding, present status and future scope. Department of Meteorological and Material Science, Indian Institute of Technology, Kharagpur. Underwater welding, Amit Mukund Joshi, Mechanical Engineer, Junior Research Fellow, Fellow Mechanical Engineering Department, Indian Institute of Technology, IIT Bombay. Among recent advances in dry underwater pipeline welding, welding engineer, 1934. Lythal Gibson, dry hyperbaric underwater welding, welding institute. So these are the references from where we are taking some suggestions. So this is the end of the session, today's session. Thank you. Thank you very much.